live! I was looking at one timer when I should have been looking at the other timer. Welcome to another edition of RockSim Live. My name is Tim. We have a number of people already in the room. Thank you for showing up today. We have Mark Gillette, Mark Sell, Galaxy Rocket Company offering a full-scale Saturn V for $500 million, $499. Oh, that's an April Fool's joke. Well, April Fools, yeah. I think the April Fool's jokes are going to be hot and heavy today, so yeah, it takes me a little while to process them. Sometimes I can't tell the real comments from the jokes. It takes me a while. Eventually I'll get there. We have Tom from Virginia, Tech and Rec. He says, hello, Elijah from Colorado, and Carlos K from Marietta, Georgia. He says that the microphone is working now, so that's good. Yeah, so let's get started. Let me switch screens here. All right, so this is my screen, and this is where we're talking about RockSim, RockSim Pro, and the launch visualizer. So I'm taking questions on any of those. If you have a question, this is where to ask it, because this is, what we're here for, to answer your questions. If you want to send me something like a file, let me know, and a RockSim file that I can open. Then I have to start up my email, but I can check my email real quick. Okay, so we have Alfred Indy from Saginaw, Michigan. Awesome. And Tom says, nice stonebreaker you got there. That's a stonebreaker. You can't see, you can see the nose. There's the tails. Okay, so RockSim, where do you find information about RockSim? Where can you download it? If you go to the Apogee website, apogeerockets.com, and go to How To and Guides, click on that, and you come down here to Software. Click on Software, and you can download the free trial. You can make a purchase. You can find out information, generic information, frequently asked questions, version history, system requirements. All that's in the left column, and then on the right side we have more of the tutorial stuff, the video tutorials where we often tell people to start out. RockSim Live training, which is what we're doing right now. Those videos are available here. There's video tutorials for RockSim Pro here. And then more frequently asked questions. The RockSim Live training, if I click on that, it shows you this. And there's a lot of topics here. So like last week, we were on episode 63, but last week was 62. And we talked about those icons in the simulation summary right there at the top of the screen. What do those mean? There's like 6 or 8 of them, and last week we talked about it. And so if you go to this YouTube link right up here, and then you go to about 4 minutes and 25 seconds into the video, you'll find where I start talking about it. So if you want to find out an interesting topic, if you have a question, we've talked about so much that there's 80% chance that what you want to know has been talked about. And you can find it here. And if you don't want to read the whole page, you can search. And to do a search on this web page, this is my favorite trick, so I try to mention as much as possible. Come to the page, and then on your keyboard, do Command F on the Macintosh or Control F on Windows. And then up here at the top of the screen, when I do it, you'll see a new search bar formed up here at the top. And then you can type in a word or a phrase, like I can type in engine edit. And it found 2 matches. Here's the first one right here, creating your own motor in engine edit. That was discussed on episode 59. And if I click the little button up here, it'll take me to the next one. And then also creating thrust curves from rocket engine data using engine edit. And then so if you went to that one at about 37:52 seconds into the video, you'd find where we started talking about that. So this is a very handy page, and I hope you use it. Let me see if we got any other questions. We have one from Tom. He asks, does RockSim offer any outputs that will help avoid fin flutter, fin failure, etc.? Fins too thin, fin aspect ratio too high, etc. That is a really good question, Tom. And unfortunately, the answer is no. And there's some reasons why. One, the big reason is we haven't built any structural analysis into the software. It would make it harder for users if we did, because, like, you know, when you go to add a new material into the database, not only do you need to know the density of the material, which is like hard enough, but then you also need to know the engineering analysis stuff, like E, you know, like these E and Poisson's ratio and all that other stuff, the stiffness coefficients and things like that. And so, you know, where are you going to get that information? And then the second part is the strength of your rocket depends so much on your own building skills. You know, how you attach the fins. You know, it's not only material, but it's how you do things. You know, are you going to put fin fillets on? You know, this one doesn't have very big fillets on, and it's a surface mount. If I put fin fillets on, it's going to change things immensely. So then we have to figure out, you know, how much strength does a fin fillet add? You know, and then how big of a fin fillet? So it gets really complicated really fast. And then finally, you know, organic materials like wood are not very consistent, like steel or aluminum, where, you know, it's going to be consistent from one batch of aluminum to another batch of aluminum. But from one balsa tree to the next balsa tree, you know, the growing season, you know, there's grades of balsa. You know, you can get really lightweight, you know, 6-pound density balsa wood, or else you can get, you know, like 12 to 14 pound really heavy balsa wood, and that's going to make a difference in strength as well. So those factors, you know, if all we were doing was engineering materials, you know, like metals and fiberglass and maybe composites, you know, like carbon fiber, maybe, but then you start adding fillets and building technique and then through the wall fins, and, you know, it's too complicated. So we'd like to do it. People asked how, you know, this is a common question, and unfortunately the answer is always that, yeah, it's so hard to figure out how strong your rocket is to determine if it's going to come apart when you launch it. They're a very good question, though. We have Rick DeFosses from New Hampshire here. And yeah, and then Tom says, yeah, and then papering balsa wood, you know, so now you're talking a composite material. You got balsa on the inside and paper on the outside. That's a composite. It's multiple materials. And then you have, what glue are you using? Are you using, you know, wood glue versus, you know, epoxy? And then, you know, the glues can make a difference too. So yeah, it's a very hard question. I did have a question from Ron Kaminsky. He sent in this RockSim file, and it was a rocket he designed, and he was looking at the rocket in 2D, and this is a two-stage rocket. So if you go here to the number of stages, it says two-stage rocket, and there are parts in the two-stage rocket. So his question is, how come I can't see them when I'm in 3D? And the reason for that is right here, this button. This shows you what stages are being displayed. So I can display one stage, two stage, or all three stages. So if I display all three, nothing shows up because there is no third stage. But if I go two stages, there's the second stage. And it would be the same thing if you were looking at the rocket in 3D. You know, you can, if you switch it back to one stage, that is gone. So your question might be, well, why don't you always display all three stages all the time? And there's a reason for this button, and it's for designing rockets. So if I go back to a 2D view right here, so right now I'm seeing the center of gravity and the center of pressure for the upper stage rocket. And that's important to know because each stage of the rocket has to make sure that that center of gravity is in front of the center of pressure. And so if I just looked at the entire rocket all the time, then I'd always see the center of gravity for the entire rocket. So this is the entire rocket center of gravity. It includes the upper stage and the lower stage. And so right now it's telling me that this rocket is stable. But then you have to check the upper stage as well. So I would come up here and just turn off the lower stage and just look at the upper stage by itself and say, yep, this upper stage is also stable. So that's why that button exists, and sometimes we just forget that it's there. And so if you're not seeing your your booster stages, it's because it got unchecked or turned off, or you're looking at the wrong stage. Normally, if you select three stages, it would show all of them. See, here I'm seeing all three stages, even though it doesn't have a three stage. But if I went to one stage, it's kind of like a little bug. It should show me the second stage is there because it should be displaying all three of them together. So anyway, that should answer that question. That's an easy question. Ron is trying to design a two-stage where the fins on the booster stage cover up the fins on the upper stage, so they're kind of like nested inside of each other like that. So that's kind of the start of this. Tom says, yes, so many opinions on adhesives. Yes, I agree. Carlos K writes, I prefer the metric system. Is there a RockSim global place where I can set all the measurements to millimeters and grams in a RockSim file? And the answer to that one, Carlos, is yes. That is, if you're in RockSim, you have to go to the preferences. The preferences are stored in different places depending on Windows or Mac. On the Mac, they're stored under the RockSim menu. You just come down here to preferences, and then I think under Windows, I think they're under the edit menu. I'm on Macintosh right now, so I'm not seeing preferences here, but I think under the edit menu you would find it. But once you get to the preferences and you open it up, you'll see this, and then you come across here the tab on the top, and you can come to units, and here there's a button that says use default metric or use default English. So if I click on default metric, you'll watch all these values change. Boom, just like that. Or use default English, like that. I kind of mix and match myself. I think in grams, but when it comes to length, I'm a feet person. And in speed, miles per hour, because that's the speedometer on my car. Altitude in feet, velocity, I use miles per hour, descent rate, feet per second, that's kind of parachute descent rate. Acceleration, I like G's. That tells me how many Earth gravity force it's feeling. Mass, I like grams. Length is inches, temperatures in Fahrenheit. Yeah, wind velocity, miles per hour. So those are my preferences. But yes, you can change it to whatever you like. You can mix and match like I do, or you can use all default metric or all default English. Okay, next question. Tom writes, questions for flight simulation. What is the best way to bound drift uncertainty? Wind gusts will vary. Wind speed may vary at different altitudes. Pick a worst case and run that. What is the best way to bound wind drift uncertainty? That is a good question. In RockSim and RockSim Pro are a little bit different here. When you go to run a simulation, let me open a new design here because I'm not sure how that one is set up. RockSim Designs, there it is. I don't know what this one is. This is a 1.9 inch diameter rocket. Yeah. Okay, so here we have a rocket, and let's see what happens when we load an engine. It tells us a 29 millimeter engine. Choose engine. I'm just going to grab one. I'll just grab an F23. And what's the I always start with the longest delay. So I always pick the longest and then click OK. So he's asking about wind. So the wind is here under launch conditions. We'll get to that. Flight events, make sure we're going to deploy a parachute at max ejection delay. So this will be 7 seconds after engine burnout, because that was this 7. That's what that means. 7 seconds after engine burnout. It's not from liftoff. It's from after engine burnout. The engine burn time, if I look at that F23, if I open that up again, I can come down here, this column here, burn time. Oops, I just lost it. 2.22 seconds. So 7 seconds after 2.22, which would be 9.22, is when the parachute's going to come out. That's what that means under flight events. Starting state, this rocket is going to go, let's make it a 48 inch, 4 foot launch rod, launch straight up. Okay, so now we're here under launch conditions. So he's asking, what is the best way to bound drift uncertainty? So how far is the rocket going to drift? In RockSim, here's the wind. So you have wind conditions, low speed, high speed, turbulence, change frequency, and wind starts at altitude. So this right here, the wind, it gives you a range of wind. It's like a calm wind would be from 0 to 2 miles an hour. And we got these definitions from meteorological terms. So, you know, if you go to a meteorological website and they say calm winds, well, what does that mean? Well, their definition of a calm wind is 0 to 2 miles an hour. So we use the same thing. So I guess you start, Tom, with, look, you're going to go out to a launch site, and you get out there and the wind is 6 miles an hour. So what I would do is I would come down here and find, 3 to 7, 6 falls right in the middle there. So what this means is that the wind is going to vary. It's going to vary. The low wind speed, because when you go out to a launch site, the wind is not constant. We know this, and I think this is the basis of his question, is the wind is not constant. So we're bracketing it, and this is where it gets bracketed. So it's a light wind, so it's anywhere from 3 miles an hour to 7 miles an hour, and it could go further than on either end, but most of the time it's going to stick in the middle there. And so what happens when you choose that, what it did here is it set the low wind speed at 3, the high wind speed at 7.9. So almost 8. So anything under 8 miles an hour and over 3 miles an hour. And then you have wind turbulence, and this is how much it's going to change, bounce from one of these boundary edges to the other. If it starts out at 3 and it goes to 7.5, how many times during any length of time is it going to bounce back and forth? And that's what this turbulence is. Right now we have it set at a constant speed. So RockSim, it's going to be random. When we launch the rocket, there's a random number generator that's going to pick between 3 and 7.9 miles per hour. We don't know what it is. It's just like in real life. When you push the launch button, rarely, unless you're watching the anemometer right there next to your rocket, there's some uncertainty there. So there's a little bit of randomness, and that when we built the randomness in there. But what we're saying is it's going to pick a number, and we're going to be constant. So from that point on, the wind for the entire simulation, from liftoff to landing, is going to be a constant number. Now, if we can select some variability. So if I select very turbulent, what's going to happen is we're going to see the wind bounce back and forth between 3 and 7.9, or anywhere between. It could go from 3 to 5, back to 4, up to 6. You know, but it's going to vary. It's going to stay in there, in that range, but it's going to bounce back and forth a lot. And I'll show you what that looks like here. And so once you set that, it puts that number right here, and it tells you what it is. And if you don't want a very turbulent day, then choose one of these other two, or you can choose your own. Anything from 0.01 to 0.09 could be your custom. So then you type in that number right there. And then you also have a wind starts at an altitude. So this is like if you're launching on a field that has a line of trees along one side, and the wind is coming from on the other side of the trees. So the trees are blocking the wind up into a certain altitude, maybe 50 feet. So what this is okay, the wind doesn't start until the rocket clears 50 feet, after it gets above that tree line. That's what this is. Okay, so we set a 3 to 7 mile an hour wind speed, and it's going to be very turbulent. So let's look at the flight profile and see what that looks like. So we're launching the rocket, and it's going to bring up the flight profile, which is this right here. And here's the rocket sitting down here on the pad. It kind of gives us an indication of how far downrange it's going to drift. Probably somewhere about 500 feet, so it's not going to go too far. But if we launch it, the rocket takes off, and it's really hard to gauge what the wind is doing until the parachute pops out. So now that the parachute pops out, it's falling. And okay, see right here, see that it was coming down at a constant rate right there. And you can tell it was a constant rate because the line of dots is fairly straight. But then all of a sudden right here, it takes a dog leg like that. So basically what happened is the wind started blowing harder, and it's pushing the rocket further away. And so now the slope is a gentler slope because the wind is pushing harder. And then if we continue to go, okay, so now here it's starting to die down again, and it's coming down more vertical. So that means there's less wind, and the rocket is falling more vertical. And so this is what you'd see when you got a lot of turbulence. This descent rate is going to change a lot. Now, if you don't like that, then use a constant wind speed. So let me go back to here. Well, let me see what the I can't tell what the wind. Yeah, the only way to tell what the wind speed was is either to graph it or to look at the flight profile again. So if you go up to the flight profile and you click on the details button right here, and it brings up all the parameters that RockSim is tracking. And we can see somewhere in here there should be wind velocity, this line right here. So at liftoff, we're just about 6 miles per hour. And as we go up higher, we're getting into a layer of less wind. So now we dropped to 5.2 miles per hour. It went up. Now up here at the top, it's at 4 miles an hour. And you know, now it's down to 3.2 miles per hour. Now we it dropped down to 3, and now it's starting to climb again. And now we're back up to 6. Whoa, now we're up to 7 miles an hour where it's falling. 7.7, 7.8. It shouldn't get over 8. And it doesn't. Now it's falling again. And you can see now it's dropping down to 3. So yeah, this was very, and then as we get close to the ground, it's starting to pick up again. You know, just watching that number right there. Okay, so that's kind of how you would do it in RockSim. RockSim Pro and the Launch Visualizer use what's called a wind table. So let me open RockSim, the Launch Visualizer, because everybody has access to that. So if anybody can use it, it's at rocksim.com. And this is called the Launch Visualizer, and it allows us to run simulations, and you can do things like what we're going to do. So first I got to log in. To use this feature, you have to log in. So you have to have an account, and it's got to be a premium account. Okay, so what was that rocket? That was, I'm looking at the name of this rocket, ASP Aerobee 300. So I'm going to upload that rocket to the Launch Visualizer. So I'm going to upload a new rocket. Click right here, click Browse. And that was in this RockSim design folder, Aerobee 300. Click Open, upload it. Error occurred. Try with a valid design. Didn't like that one. Well, let's try a different one. It's been a while since I got something like that. Try an Amarok. Upload. Okay, it uploaded that, and it will show the design here in just a second. So there it is, out sitting on the launch pad, and this is 3D. So we can see this blue arrow here is the current direction of the wind, and it's coming out of the west. And that's what this screen is for, is to kind of give us a lay of the land of how the rocket is oriented to the wind. So we need to pick a launch site, and I like to, every time we do one of these videos, I choose a different one to kind of give some publicity to one of the NAR sections around the country. And I'll just grab one, Gorge Rocket Club. So I don't know anywhere where this is, and it will show it on the Earth here in just a second. It's loading a map. It looks like we're on an athletic field somewhere. Looks like we got some trees over here, and these are nice in linear fashion, so I'm guessing that's some kind of grove. Let's see where this is. The Hood River. Okay, so this is, here's Washington State right here. Here is Oregon. So this is just like right in Oregon, northern Oregon is this launch site. This is a nice, look at all those trees. Okay, so that's where we're launching from, right there in that in the middle of that football field track area. We don't want to land in the trees, and we don't want to land on the gymnasium. And there's not a lot of good areas. This little area right here. So I need to launch to the northeast. So keep that in the back of your mind, because then we're going to go to the starting state, and I'm going to angle it to the northeast. So here's the compass rose. So now it's going to the northeast, and now we got to set our wind. And so here is, this is similar for RockSim Pro and the Launch Visualizer. Right now it's a steady wind at all altitudes, and if you just select it, it'll tell you what it is. Coming out of the 270 direction, I got almost a 5-mile-an-hour wind. But what we can do here is we can create a wind table where we have different wind at different altitudes. And not only can we have wind coming out of different speeds, we can have different directions. So at ground level, it might be going this way, and up altitude, it might be going this way. And that's called a wind table. So for here, I'd go to the wind model, go to a variable direction wind table, and this is an advanced feature. So right now, altitude above sea level, this is sea level. So now we need to know what is our current altitude at ground level. So we need to put that in to the back of our mind. So I'm going to cancel here, and I need to find out what is our ground elevation. So I'm going back to the launch site, and it shows me my ground altitude above sea level as 710 or 711 feet. So my first, to set up a wind table, I'm going to go, highlight that field, altitude above sea level, 710.8 feet. Okay, so what wind do we want? Let's say it's blowing at 5 miles an hour. No, this is a direction. So here's the compass rose. 0 is north, east would be 90, south, coming out of the south would be 180, and coming out of the west would be 270. So the direction, I'm going to say 270, and let's call it 5 miles an hour. Oops, not 50. And then I need to add another row. So the next wind, let's say 1,000 feet up in the air. That's 500 feet. So we need to add 500 feet above 710. So that's going to be 1,200 feet. I'll just round it up, which is 500 feet above ground level. This is the hard thing you have to remember. A lot of times when you get a wind, we talked about this last week, if you go to a meteorological site, like a weather website, sometimes you can get wind, and they're going to give you wind usually above sea level, because they're doing it for pilots, you know. And if I'm flying in an airplane at 32,000 feet, that's 32,000 feet above sea level, not 32,000 feet above ground level. Like here in Colorado, you know, we're starting out at 5,000 feet, so then you'd add 37, that'd be 37,000 feet. So I think they give them to you in above sea level, which is why our table is above sea level. Oh, look at this. It tells me right here. I forgot about that feature. It tells me my current rocket altitude is 710 feet. So now let's make the direction still 270, but let's change it to 10 miles an hour. So, oops, 10 miles an hour. Okay, and then let's go another altitude at, let's call it another 500 feet would be 1,700 feet. Let's call it, again, we'll keep it all going in the same direction. And then this one, we'll drop it down again to, let's make it 0. So it gets really strong, and then it's 0 right there at the top. Hit tab. Okay. All right, so that's a wind table. And you can see it reoriented, you know, the lowest altitude to the highest altitude. And I'll click OK. Let's save this wind table. I got to give it a name. So let's say wind, it's all caps, from the west, variable, and click OK. Okay, so now we're ready to launch. We need to pick a rocket motor, and I want to choose a big motor because I want it to go really high. So let's go like a G motor, but I want to go low thrust. So G25. Yeah, I like that motor. So what I was looking for is, you know, a low thrust motor. I can tell it's low thrust by looking at the engine code. The lower the number after the letter is the average thrust of the rocket motor. And it will also tell us the burn time right here, 5 seconds. So, you know, if I'm looking for a long burn motor, I could either look here or I could look here. This gives you the exact, and I was also looking at the total impulse. Like this G motor has more total impulse than this G33. So that's kind of like how big is your gas tank. So this G motor has a bigger gas tank than this one right here. They're both G motors, but that one is more bang for your buck. All right, and then so we're going to select an engine delay, and I'm going to select 10 seconds, click OK, and go to flight events, and this has a parachute in it, and it's going to deploy at maximum injection delay. And so we just talked about what that means, so let's launch it. Simulate it. Okay, and it's loading, and so there's our rocket sitting on the pad. And the pad is underground because our altitude coordinates are just not quite what we'd hope. So there's the rocket sitting on the pad, and let's arrange it so north is straight up. So I'm looking at the compass wheel down here. I'm just spinning it around until that goes to the north. And yep, so remember we wanted to try to land over here in this field up there. But we've got a wind that's coming out of the west, and it's going to blow it across from left to right. Let's look at it from a trajectory view, and it reoriented my map, of course. So I'm just going to spin it back around. I want to make sure I'm seeing the trajectory here. So I went to the preferences. Remember my camera view, show me the path. That's what I want to see. And the extruded ground path. That will give me kind of a curtain. Makes it a little easier to see. And if I wanted to move that launch pad above the ground, I would use this ground elevation adjustment right here. You can kind of see the rocket here in the corner. And if I move it, see I moved it, you can see the pad just basically down here in the corner. Now it's above ground. That's how you fix that problem. And then click OK. And okay, so remember our rocket, let's see, it's right here where my pointer is. And it's going to launch out of there, and it's going to be in the air 68.87 seconds, and we launch. Okay, so the rocket's taking off. It is going towards the northeast like we want. There's the ground path right there, and it went out of my screen. And right about here is when the parachute should come out. And okay, so we're at an altitude of 1,000 feet, so we're in that 10-mile-an-hour range, I think. And the rocket should be coming down, and it's right there right now. And you can see, looking at this trajectory, that as soon as the parachute opened right here, it fell like a rock for a little bit of ways. It's because there was low wind speed, so it fell fast, and then it got into this higher wind speed, and you can see it's curved because it's not a constant wind speed blowing. And then like what we saw before in RockSim when we looked at the 2D flight profile, you know, you can see by the curve that we're going into higher wind speed, and then it's starting to curve back around, so that means we're getting into lower wind speed. So down here towards the ground, we're in lower wind, and you can see that we're also in the trees, which is not good. So how would we change this to land over here? And I think the obvious choice would be, instead of launching towards that field, we probably should be launching to the northwest so that when it comes down it lands over there. So let's change the launch direction. Let's switch it around to the northwest. So I'm just grabbing the pointer over here. Okay, so now we're towards the northwest. And launch it again. Just click the little launch button down in the corner, simulate it, and see where this one ends up. Okay. Again, our rocket pad's below the ground, but I don't care. Let me orient it around to the north. So that north is pointing up. And let me zoom out a little bit so we can see it. Okay, so the rocket is right there. And our goal is to land right there. Let's see how we do. Well, before we landed way back here, so we might land somewhere over here. It's going high again. Let's see, we're at 1,200 feet, arcing over. And while it's coming down, while you're doing that, I will look at the questions. If you have a question, you're welcome to ask it. We still have some time left. Tom writes, good review. Didn't catch you have a variable for thermals as well. Yes, there is the thermals in RockSim. Not in the launch visualizer, though. We have Fat Bank from Katy, Texas. And Tom says, the dangers of live demo. And we have Pyro Pagerick. He says, greetings from New Zealand. Cool. It's like really early in the morning there. And we have Josh from Massachusetts. Okay, so the rocket's coming down, and this time it's landed right there in those trees. So let me move the flight time all the way to the end. Just grab it and drag it. It's a little bit sluggish when you're online. Again, it came way over the top. So here was Apogee point right here. It went way over the top before ejection happened, and now we're landing in these trees. Again, you can see the trajectory. It fell fast, and then it started slowing down, but as it got closer to the ground, it started going fast again. Okay, so let's play with this. Let me show you a fun thing to do. Now, on our wind table, we had all of our wind coming strictly out of the west. So now let's change those layers. So this first one's going to come out of the west. We'll leave that one alone. At 1,200 feet, let's see if we can edit that. Yeah, you click on it so you can edit it. Let's change it from the north. So from the north, the compass direction is 0. And we'll keep it at 10 miles an hour. And then at 1,700 feet, let's change it. Come on. I want to edit you. There we go. Let's change this to 90 degrees. So that means it's coming from the east. So at the ground, it's coming out of the west at 5 miles an hour. At 1,200 feet, it's coming out of the north at 10 miles an hour. And at 1,700 feet, it's coming out of the east at 90. Well, it's 0 miles an hour. We better give it some speed. We'll make it 20 miles an hour up at the altitude. Click OK. This time, what I'm going to do is I'm going to change my parachute. I'm going to have it deploy at Apogee. So it's going to deploy right at the very top. So no matter what happens, it's at the top. And let's just launch it and see what happens. Okay, so there's the rocket. I always have to reorient my compass. So north is straight up towards the top of the screen. And zooming out. There's the athletic field and the soccer fields, more soccer fields, and a lot of trees, which we don't want to land in. This is what the purpose of the launch visualizer is, so you don't have to land in those trees. So, okay, so the rocket's going up. It's really arcing into the wind. Okay, so there's Apogee, and then there's parachute ejection. And okay, so since we're at altitude, remember at our high altitude above 1,700, we were coming out of the east, and then as we drop lower, then it comes out of the north, and then as we get closer to the ground, it'll go back to the west. So if I look at it from a top view, you'll see that the rocket is It's making a come around. It's going to make a nice little circle. Oh, look at that. It's going back that way. Did I? We're still at 200 feet up in the air. Boy, it's circling around. Hope I'm not making you dizzy there. But you can see the path. I'm going to pause it here right when we get to the end. Oh, I paused too late. Grab that slider. Come on. Ah. Come on. There we go. Okay. So now you can see this red line here is the ground track, and it circles back around. So why does it disappear? This is because the earth terrain is changing underneath the ground track. So basically there's like a little bump in the earth in this area here, and so our ground path, it thinks that the ground elevation was it 710.8 feet, but in real life the ground is actually, you know, the earth always has variability to it. But so you can kind of see, that's why I threw the curtain up there, which is called the Extruded Path. So it kind of gives you an indication right here where that would be, and then the ground path came above the earth again, and then it went below, and then it came around. You can see it did a nice little curve, and if I look straight down on this, you can see what that looked like. So here I was thinking about having a contest for people to create variable winds like this in the launch visualizer and send them to me, and see if you could make various shapes. Like, can you make a figure 8? We had the start of one here. I've done a number 2. So at launch it does this and then comes back around, and this is like looking straight down on it from a bird's eye view, to see what kind of paths you could make. It's very interesting, you know what the wind does at various altitudes. You know, if you have wind going in different directions, it's typically not 180 degrees apart though, like that. That's a wind shear. Ooh, that's a terrible wind shear. That's kind of like, you know, tornado type stuff. Yeah, a tornado would be like that. Anyway, so that is playing around with the wind and how you would bracket what your wind would look like. Last week we talked about a website called windy.com. So if I open a new browser and you go to windy.com, you'll get wind maps, and somewhere over here you have to have wind turned on, and if you can see the direction that the wind is flowing. So here's Denver, Colorado, and we must have wind, you know, coming north, and then it swings around this way, but then that's surface wind. So if I bring up to 5,000 feet, yeah, it's pretty much blowing in the same direction, but sometimes you can get, you know, wind shear at different altitudes. So this is where you could build a wind table right here of altitude and wind direction, and you'd kind of have to, you know, look at these arrows to try to figure out which direction it's blowing. So like these arrows are kind of blowing this way, so that's kind of the southeast. So then I would go into the launch visualizer and say, okay, what direction is that? And so I would come here to the compass and I would just kind of match it and say, okay, so that's to the southeast. And okay, that's 140 degrees. And then I would go into my wind table and type in 140 degrees for that altitude. Okay, so that's wind. Everything you wanted to know about wind in RockSim and the Launch Visualizer. And RockSim Pro is just like the Launch Visualizer, where you can make wind tables. And so you might make several wind tables. That's why we allow you to save your wind tables, because it is a chore to put them in all the time. But once you have one in there, then modifying it is pretty fast. Okay, newtons per second, or who is Josh from Massachusetts, says, I want to add smaller body tubes with a nose cone to the four sides of a larger airframe. How do I do this without the smaller airframe showing inside of the larger airframe? Okay, that's a good question. We can try to answer it. So, I'm going to close that, close Windy. Okay, so I'm in RockSim. Okay, so I'm going to take this design right here, and he wants to add 4 tubes to the outside of this. So to do that, you come here, the Design Components tab, click on that, and so now you have to decide where you're going to add these tubes. Are you going to add them to this tube right there, or this tube right there? Probably that tube right there. So you just highlight it, and it will highlight it up here. And that's kind of like, in this design, the person that created it has body tube, you know, so you got multiple body tubes in there, and just by looking at it, it's hard to tell which one is which. That's why we added this feature where you could click on the parts and it would highlight it in the parts tree. But I would always recommend that you gave them distinctive names. Like this front one, I might call it, you know, like the payload tube, and the back one I would call aft tube, and this body tube here, this one would be engine mount tube. I'm pretty sure that's the engine mount tube in the back. Okay, so newtons per second. You want to do with nose cones. But you did not say if you wanted fins on them. That's what I was looking for. Okay, so we're going to add to this body tube. So now that it's highlighted, we're going to add what's called a pod. Anything that's strapped on the outside of the rocket, except for fins, would be called a pod. And so we're going to strap something to the outside of the tube, and a pod is like a placeholder. And it's like this right up here, this sustainer, that's a placeholder. So we're adding parts to it. So we're going to start with a pod, and then we're going to add parts to the pod. We're definitely going to add a nose cone and a body tube. So, I'm going to select pod over here, and it brings up the pod design. And currently, you can tell where it's located right here by this little icon. And we can adjust this later, so don't worry about that right now. And we'll come back to this. And this little check mark here that says this pod can be ejected during simulation, that means it's a strap-on pod that can fall off. Like on the space shuttle where the pods would fall off. If you don't want them to fall off, and you click and say, keep them on. Right, so that's what that is right there. We're going to start with these, keeping them on the rocket. Okay, so now it added the pod, and now we're going to start adding parts to that pod. And so we're going to add a nose cone. So I can select the nose cone. You can see that it is an active component versus these other ones over here are inactive. You can't select these, but you can select any of these. So we'll add a nose cone, and it's going to bring up the database. And we'll select, I'm looking over here at the diameter of this thing. So this is 1.8, so we want something smaller than that. So let's go with a plastic nose cone 24A. So if you need to know the diameter, just scroll over. Here's the diameter, 0.976. That tells me that this is definitely smaller than 1.889 right here. So I'm going to click OK. And you can see then it placed the nose cone right there. Okay, I like that. So we'll accept that, and everything looks pretty good. Just make sure that we have a material selected. I'm happy with it. It tells me that the component weighs 4.587 grams. So I'm going to click OK. So now we have the nose cone right there. Now we're going to add the body tube to the nose cone. So click on the body tube. And so now we need a body tube that matches, and that was a 24 millimeter. So I'm looking right here, 24 millimeter. That's how I know which one to pick, although it says it's 6 inches long. Well, here's another one right up here at the top. This one will probably be a lot longer. This one doesn't tell me the length, but I can adjust the length. So I'll click OK, and there's the body tube right there. Let's make it a little bit shorter. Right there, and then let's click OK. Do we want this to be a motor mount? You can put motors in it if you want. Let's put one in. Click OK. So there's the tube. So there's the whole rocket together. And if we look at it from the back side, we can see that it's in line with the fin, which is probably not good, but we can adjust that. So now how do we move it back here to the bottom and adjust it? And to do that, you just go to the pod and we'll edit the pod. And all the components will move with it. Okay, so double click on it to edit. And all right, so we have location from the front of the owning part. So the owning part is the tube. So the front of the owning part is right here, and right now it's set at 0 inches from the front. So that's why this icon is in line with this edge right there. And if we move it back, you'll see the whole pod moves back. Let me zoom out. And we want to move it back probably until it's at the base of the rocket. Let me zoom in here a little bit. See if I can make this bigger. I did. Okay, so I'm looking at this line right here, and I want to move it until it gets down to the bottom. And it's really touchy. Okay, so let's call it 7.6, 7.2. 7.2 is too little. 4 is too little. 5. Okay, 7.5 inches makes it perfect. But now, remember, if we look at it from the base view, it's still in line with this fin. So now we need to move it off to one side. So you do that with the radial position tab. And you have this little slider right here, and I can just slide it around. And you can see as I'm moving it around, it's sliding it around the outside. And we'll probably want it like right in the middle. If you were to put 2 on here, what you would do is you'd put it, probably nest it right up against the fin. So let's call it 23.5 degrees. So 23.5 plus 90 is, no, 180. 23 plus 180, what is that? Let me get a calculator. Here's a calculator. 23.5 plus 180 degrees is 203. No, this is a minus 25, minus 23. 23 negative plus 180, 157. So if we set the second pod at 157 degrees, it should be right over here. And so then they would be all in line. That's how you would do 2 pods on a 3-fin rocket. Okay, so now we have our pod, and I can duplicate this pod just by doing a right click on it and do a copy. You can also do it up here under edit, do a copy, and then you can paste it onto the body tube again. So select the body tube and then select paste, and you can see I should have 2 pods now. Did it not paste it? Paste. Okay, so now I have 2 pods, but they're on top of each other. So this second pod, if I open that up and if I set this one at, what did I say, 150 something degrees? I forgot what it was. That was here. 153 or 157? It's probably 150. Does that look like they're all aligned? It's pretty close. Okay, so now I have 2 pods added to the rocket, and these, I do not think I set it up to that so that they are motor tubes. Because if I went here to load a motor, oh yeah, it does show them as motor tubes, so I can load motors into these. Let's do a D12 plugged, since they're not going to fall off. So we have one of them in the first one, and then I'll just load all, and it loaded it in the second one. That's the fast way to load them in, is just use that load all button since they're identical. Click OK. And they're in the tube, but I didn't hang them out the back with the engine overhang, so that's why they're flush with the tube right there. So hopefully, Josh in Massachusetts, that answers your question. How to add smaller body tubes with nose cones to 4 sides of a larger airframe. I did 2. You can figure out 4. Just copy and paste 2 more times. He says fins will be in between. Yeah, when you got a 4, you probably have a 4-fin rocket. I had a 3-fin rocket. Carlos says, question, is there a preference setting for zipper speed to warn us of the dangers from a fast ejection speed? How about a fin buster speed for fast impacts? The fin buster speed, that's the question that Tom asked earlier, is can RockSim figure out how strong your rocket is? And unfortunately we can't. Zipper speed, yes, there is under, it's either, I think both of them have them, flight simulations and recommended motors. See this column here that says safe deployment? That's your zipper speed. And you can show that under flight simulations as well. So if you want to show, what do we call it, safe deployment, you just come here to the top line, or top row, and right click and say organize columns. You know, it brings up that little menu. And then you can say, what do we call it, safe deployment speed? Safe deployment, right there. Now this is a true or false. So you're not going to get a number, you're going to get a true or false. And right now, all of these say NA, and except for this one down here at the bottom, this last one, I think, did we run that? Yeah, that's the one we just ran. It says that one is safe. So what it's looking for is velocity at deployment. And if the velocity at deployment is less than 50 miles an hour, that's the trigger for safe. So if it's greater than 50 miles an hour, then you'll probably get unsafe. So we can set up a simulation real quick. So we already have this loaded. So what we want to do is have that deployment speed where it's coming down vertically, and as it's coming down, it's gaining speed. So we want this to come over the top and come down. So we're going to have a really long delay, and I'm going to choose a custom delay, and let's choose 11 or 12 seconds as our custom delay. Choose that. We want it to deploy before it hits the ground, but at a high speed. So the rocket should go up, come down, and if you don't know what number to pick, just choose a really high, well, just say you don't know what number to pick. Here's what I would do. Make it plugged. You're going to run 2 simulations. The first time it's plugged. So this time the rocket's going to go up and all the motors are plugged. So it's going to hit when it hits the ground. And so make sure the flight event says deploy a maximum ejection delay. The maximum is plugged. Plugged means infinite. So it's an infinite time from engine burnout. So that rocket's going to hit the ground. And so last week we talked about you're going to get a crash icon over here under the results. So let's launch it. Okay, and we did get the crash icon, and it tells us the optimal delay is 9.1 seconds. So the apogee point would be from motor burnout 9.17 seconds. So if we selected, that as our delay, that's would be right at apogee. Total flight time, we can also see total flight time. Again, organized columns, and time to apogee, total flight time right here. Select that, and we'll put another column right here. Click OK. Okay, and this last one, 25.88 seconds. So from liftoff to crash is 25.88 seconds. So I want a number somewhere between 9 seconds, right at top, and 25.88. And I want it to be coming screaming down. So the closer to 25.88, the faster it's going to be. So if I pick like 20 seconds, it's going to be really low. So let's run the second simulation, and we'll change the ejection delay to 20 seconds. You can just type it in right there. Hit tab so it accepts the number, and then do launch. And this time we should get a parachute, and the arrow should be pointing downwards. And here is unsafe, like we expected, and the velocity at deployment, which is this column right there, 165 miles per hour. So it's screaming into the ground. Yeah, safe deployment, unsafe. So yes, zipper right there. And it could mean either zipper or your parachute shreds, because I don't know how many parachutes are designed to open at 165 miles per hour. But it's definitely unsafe. So it's not as technically a zipper speed, but anything above 50 miles an hour. Imagine driving in your car on the interstate at 50 miles an hour and throwing out your rocket with a parachute. Will you zipper or will you shred your parachute? That's the way you would probably test it if you wanted to figure it out. That would be a simple test. Just hold your rocket outside the window, throw the parachute out, and see if it shreds the parachute or it zippers the tube first. Because eventually you're going to shred the parachute, because at 50 miles an hour, if it hangs out in the wind long enough, it's probably going to rip the parachute shroud lines off. Tom says, fin buster is a hard landing speed. Yeah, and again, I don't know what a hard landing speed is. It depends on how rugged your rocket is built, and I don't know. Like on this rocket right here, this is a balsa fins, although now we've changed the rocket to have basswood. Basswood fins and just surface mount fins, so they're not through the wall. So when this thing hits the ground, at what speed would you break those fins? I don't know. You're probably going to crush something down here first, because usually it hits something. With these fins that angle forward, it's going to hit the tube first. And if you hang your engine out the back, then it hits the engine first. And that's a trick that I like to use as much as possible. When it hits the ground, land on the engine instead of the tube or the fins, and that will save your rocket from a lot of damage. Fins that hang off the back of the rocket, like the one that we have just shown on the screen, those would probably crunch the fins first. Okay, we had a lot of good questions and a lot of great people. That's you, and that's not an April Fool's joke. You are a bunch of great people for showing up here at this weird hour of the day to watch RockSim live, and I appreciate it. No one's gave me any April Fool's jokes. I'm the April Fool. I'm always the joke. Things always happen with me. So yeah, again, I appreciate you coming. We will be back next week, Friday, same time, which is 2 p.m. Mountain Time Zone, Daylight Savings Time. And that's 4 p.m. on the East Coast. I do not know what time it is in New Zealand. It's got to be like really early in the morning. So thanks for coming. We'll see you again next week. If you have questions, you can forward them to me ahead of time. Just go to the Apogee website and you'll see the Contact Us link. Click on that, and I read all the emails that come in through there. If you want to send a file, just say, I'd like to send you a file, and then we'll email you back, and then you can just reply. And that way you'll have our email address. We don't put our email address out there because we get enough spam as it is. So we're kind of very cautious about giving away email address. We treat your email, if you ever email us, the same way. We don't give it to anybody. And if somebody says, hey, do you know so-and-so? I know he's a Rocketeer and he's got to be in your database because he bought this item from you. Can you give me his email address? And the answer is no, we won't. But what we can do is we'll contact that person and say, hey, so-and-so over here would like to talk to you. And then we'll connect you. But yeah, that takes a lot of time. I shouldn't have said that because now everybody's going to ask us for email addresses, and we don't want to do that either. He says it's 10:10 a.m. over where he is. Pyrotech. That's in New Zealand? Wow. I would say 10:10 p.m. maybe. Huh. Okay. So we'll see you next week. So in 5, 4, 3, 2, 1, go out and launch something.